Alrighty folks, so in this video we're going to talk about an example of calculating the average rate of change. And so I think actually calculating the average rate of change itself is not really the tricky part. The tricky part is this first question here actually. So let's take a look at that. Our function that we're looking at here is f of x is equal to 2 over x plus 1. And so remember, our average rate of change is really just a fancy way of saying the slope. Except now we don't actually know where the endpoint is. We know one of the points is 1 comma f of 1, but the second point is it's a generalized term, so it's just x wherever x happens to be, comma f of x. And so if I had to draw this graph, well, first off, I think our graph is going to look something like so. And we'll talk in the future about how I know generally what the graph already looks like. But if here's -1, our graph's going to look something like so, and actually down here as well. But we're looking at where starting off at x equals +1 right there. Okay, so this point right here, that's the point 1 comma f of 1 right there. And somewhere along the way, x could be maybe here. This point right here is x, because that's the x value that goes in. And whatever comes out is, well, you're going to have to just plug in x into the function. And so really, the average rate of change is just the slope. So I'll abbreviate, I guess, the ARC, which is really just slope again, is just, let's see, delta y over delta x. And so for us, in this equation, that's just going to look like, well, f of x is, well, sorry, let me take one more, show all the steps here. F of x, that's, one of my y values, minus the other y value, which is f of 1, divided by, well, the second x value is x, and the first one is 1 here. Alrighty, so just in the interest of space, I'm going to kind of erase and pull this back. But this now just looks like so. So let me drag this, I apologize, over here. All right, so this now, well, f of x is our original equation, which you see down there. I actually have no idea where I'm pointing because I can't actually see my camera, but I think it's over there. So that's going to be 2 over x plus 1 minus, well, let's plug in 1 now. So if I plug in 1, I'll get 2 over 2, which is just 1 here. And on the bottom of our fraction, our denominator is just going to be x minus 1 again. Alrighty. So actually, we could just stop here if we really wanted to. And I could plug in the next question, find the average rate of change from 1 to 2 by plugging in 2 for the x here. So again, this 2 is basically where it is. It's going to just go in for x there. But this is kind of messy, and depending on the result here, it could, again, get really messy in the future. So I would actually want to simplify it whenever possible. Now, how could I simplify it? Well, I got a compound fraction, or a fraction within a fraction. And there's a couple ways you could deal with this. Here's just one way. Well, I know in the numerator, you're dividing by x plus 1. And so think back to just how you undo division. Well, I'm going to take care of that by multiplying by x plus 1. And so I'm going to multiply that entire top, the entire numerator, by x plus 1. Now remember, I don't want to actually change the value of this fraction, and so anything I do to the top, I have to also do to the bottom. So I'm multiplying this whole result by x plus 1 over x plus 1 actually. So what happens? Well, here's where you want to be careful, because again, we're distributing across the entire term here. So I'm going to distribute this x plus 1 into this and into this -1 right there. And the reason I'm doing this very carefully. So 2 over x plus 1 times x plus 1, well, those x plus 1s are going to cancel out. Remember, that's the whole reason I did this. And so I just have 2 right there. And the next part here, I'm going to just do it like this, minus, well, x plus 1 distributed into 1 is just minus the quantity x plus 1. And so now on the bottom here, I'm actually not going to distribute that. I'm just going to leave it like so. And you'll see why in a second. So I I remember taking a look at a couple people's homework. You really want to do this. I know you want to. Remember, we cannot do that because we're not multiplying by x plus 1 on the top and bottom here, because it's 2 minus x plus 1. So be careful of that. But when I clean up the numerator, you'll get, let's see, 2 minus x plus 1. So I'm going to continue down here. So 2 minus x, so that's going to be a negative x, but 2 minus 1 is going to leave you with plus 1 over x minus 1 times x plus 1. Alrighty. Now it looks like there actually should be something to simplify here because it looks so close, but we don't quite see the same factors on the top and the bottom. But you might notice this. If on the top, if I could change that negative x to a positive x, I might be able to do something. We could actually do that by factoring out a negative 1 into the numerator. And so I'm going to end up with this negative, and then what's left would be x minus 1. And now we can see, oh, hey, in the numerator and denominator, there's an x minus 1, and so those I can cancel out. And so your actual final equation here should just be negative 1 over x plus 1. And so what does this mean? Let's think back to what this means. This equation right here that I put in a blue box, if you want the slope of this secant line, I wish I had my ruler, but I don't, right here. This green one that I'm going to draw on the graph here, this secant line right here, the slope of this, depending on where x is really just negative 1 over x plus 1. That's what this is saying. And so if that x value is 2, if we go into part B here, the average rate of change, or the slope of the secant line from 1 to 2, again, these are x values, x equals 1 to x equals 2, that would just be, plug in x equals 2 into this equation, and you'll get negative 1/3. We could also see that if I had plugged this into the red equation, the big mess here, it would have also worked. So I'll plug in 2 over 2 plus 1 minus 1 over 2 minus 1. So let's see, 2 minus 1 is just 1, so I don't have to worry about that denominator there. Let's see, I'll get 2 over 3 minus 1. 2/3, take away a whole 1, that's going to be negative 1/3. And so we still get the same answer. It's just, it's much cleaner if we simplify it first. The last part here is we want to find the equation of that secant line. And the easiest way to do this would be to use point slope form. So again, point slope form, remember from algebra 1 or maybe algebra 2, it's really just this. Once you know a point, if it contains the point, I'll call it PQ, that's usually how I like to abbreviate it. It's y minus the q, the coordinate of the point, the y coordinate of the point you know, equals m, which is still the slope, times x minus the p, which is the x coordinate that you know. And so we know, well, we can just plug in either of these points to get the right one. So I'll use 1f of 1, 1f of 1, which is really, let's see, when I plug in 1, I will get, let's see, 2 over 2, which is just 1, I believe. Yeah, okay. So now my equation is just y minus 1 equals our slope, which is negative 1/3, times x minus 1. If I wanted to clean that up, you can move the 1 over, but this is good enough for now. Alrighty, so hopefully this video helped you. Again, this is the tricky part right here that I'm going to highlight in this light blue color in a second. This is the tricky part, and it really, again, just takes some more practice and just reminding ourselves of how do we know how to simplify different kinds of expressions from algebra 1 or algebra 2. Alrighty, thanks for watching the video, and I'll see you in the next one.